Hello students, we will continue this chapter boolean algebra, chapter number 2, and this is the class 3. Okay, so 2 classes are over on this boolean algebra. So today in this class we will see the topic evaluating of boolean expressions using truth table. Okay, so here I have written some points and everyone will consider some problems. Okay, so here there are 2 problems, here I have written 5 problems. So first of all, just remember what do you mean by boolean expression or logical expression. So it's an expression containing only the logical operators and binary valued quantities. So binary valued quantities means they may be either variables or the values. So variables, they should have either 0 or 1, or else you have to consider 0 or 1 for the given variables. And if values are present in a boolean expression, they have to be either 0 or 1. So a boolean expression is a type of expression where we see logical operators and binary type variables and binary values in the expression. So logical operators means they are and or not. So here I have written an example: x, or operator, variable y, and operator, not operator, and z. So in the last class we came to know that it is not necessary to write the words, we can use the symbols also, so that the expression will look simple. So now this lengthy expression can be written in a simple way using the symbols. So for or, the symbol is plus, then the variable y, and means it's a dot symbol, not means it's a complement. So we are having some options, but still we prefer the bar symbol, okay, complement symbol. So z, this not is a bar. So it's just x plus dot z bar. So even dot is not required. Okay, so it is not necessary to indicate the AND operator with dot. It's understood. So it's an implicit case. So you can write like this: x plus y z bar. So this is equivalent expression of that expression. Okay. So it is not about only the variables here. Even you can have values like 0 and 1, the binary values. Okay. Say for example, if I write here as 0, okay, still it is allowed, still it is an boolean expression, because we are having the variables which are 0 or 1, or the values, direct values which are again 0 or 1. So x plus y, here instead of z, it is going to be 0 bar, 0 complement. So it's about the boolean expression having boolean operators and binary type variables and binary type values. So truth tables are used to study the boolean expressions. Okay. So truth table means what? The definition: it containing all possible values for the given variables with corresponding to their output values or results. So we have to prepare truth tables to study the boolean expressions. So at the time of evaluating the boolean expressions, okay, so we have to follow the precedence rules. So here boolean expressions are evaluated according to the precedence rules. So precedence means the priority. So for which operator we have to give first priority, for which operator the second priority, for which it is third. Okay. So here there are 3 logical operators. Okay, and or and not. So when it comes to precedence, for not we have to give higher precedence, first preference. So for not it's the first priority, for and it is second priority, for or it's the last priority or third priority or precedence. So we have to follow the precedence rules. one more thing, if the parentheses are there, okay, if the brackets are there, we have to first solve the expression, part of the expression which is there within the parenthesis. Again in the parenthesis, we have to follow these precedence rules. Okay. So now we will go for considering the problems. So here there is a question. We have to verify given boolean equation using truth table. So here there are two problems are there. So it's all about we have to construct the truth table for the given equation, boolean equation, and he is asking us to verify. Means they are going to be equals to symbol. So we have to check the answer of this part of the expression, LHS expression, with the RHS expression. So if both are same, then we will say it is verified. So let us take the first problem. X plus xy equals to x. Okay. So here already I have written the truth table. Here it is about two different variables. So if you observe the expression here, equation x plus xy equals to x. So only two variables we are having in this expression. So these are the, you can say, two given variables in the given equation. So when I have the two variables, we will be having four possible combinations of zeros and ones. So usually we will write them in this form: 0 0, 0 1, 1 0, 1 1. So it is the standard way of writing the combinations of zeros and ones, which is of course according to what? With their decimal equivalent in increasing order. So this one is actually the binary number of decimal value 0, this is 1, this is 2, and this is 3. So we are writing in an order so that we are comparing with the decimal values, and that too in what fashion? In an increasing order. So in any order you can write, so there is no any hard restrictions, but still we follow this conventional order. Okay. Then if we look at this equation, okay, x plus xy equals to x. So two given variables and all the possible combinations we have written. So first of all we have to clear out this one. So given variables, different variables of course, and then we will concentrate on the equation. So at the LHS, so it's about part by part we have to consider. So it's just an x variable. Here it's a plus means or. Here nothing is there means it is dot. Dot means it is AND operator. So first consider this part of the expression. Okay, x into y. So here you consider that column x into y. Then after having the answer of this x into y, then we can go for logical OR with the variable x. Okay, so let go for this x into y. So this is an AND. Okay, so AND property says that output is 1 when all are 1. So this is the only case where we are going to get 1. So remaining all are 0. So now this part of the LHS is solved. Okay. So now we have to go for ORing with variable x. So then what we can do? You write one more column. Now consider complete LHS part x plus xy. X is ready, this column plus x into y. So x into y also ready, we have solved it. So now what we have to do? Consider these two columns. This is the x and this is x into y. In between this is plus. So it is logical OR. So what the logical OR says? Answer is 0 only when all are 0. Otherwise it is going to be 1. So that's why look into these values. This is x, this is x into y, in between OR. So all are 0, then it is 0. So here both are 0, again it is 0. Here one of the variable is having 1. So now answer is 1. So here both are 1, no doubt it is going to be 1. Now this is a column of LHS. Okay, left side part of the equals to sign. Now what about RHS? It is just X. So again it is going to be this column. So now finally what we have to do? Okay, this is what your RHS. This is your LHS. Now observe the values. So the values are identical. The values are same. So that's why it is verified. So this much x plus xy is nothing but just x. Okay. So finally we have to write the conclusion in the examination. So just write a sentence. Okay. Say in the above table the columns. Okay. The columns x plus xy. Okay. And this column x are identical. Hence it is verified. So we are having one more problem here. Here x plus y whole bar equals to x bar into y bar. So here also in this question again if you see only we are having two variables. They are just repeating. So how many different variables we are having is only two, x and y. So again we are going to get 4 possible combinations of zeros and ones, and even the variable names are again x and y. So in the previous problem itself I can go for some changes. So now we will consider the second one, x plus y whole bar equals to x bar into y bar. It is actually one of the De Morgan's theorems. Okay, we will see later on about that one. Now we will just prove that this part of the expression gives the same values of whatever the values we are getting for this part of the expression, x bar into y bar. So okay, x and y, two variables. Next I need, say here in the LHS side, I want x plus y first. So first we will go for x plus y. So first it is about x plus y. Then what we will do, we will go for x plus y whole bar. Okay. Meanwhile, of course, at the RHS side, we want x bar and as well as y bar. Okay. So I will go for two more columns here, this side. So better we start with x and y, then we will go for x bar and y bar because we need x bar and y bar on the RHS side, and at the LHS side x plus y first, then x plus y whole bar. Okay. So these two. So 0, 0, 0, 1, 1, 0, 1, 1. Now x bar means just take the value of x column and opposite of that one. So x bar complement of the x. So here x value is 0, now x bar means it is 1. Here 1 it is 0, here 1 it is 0. Similarly, y bar. So whatever the y value here is, you just write the other value 0, here it is 1, 0, 1, and here it is 0. Now we will go for this x plus y. Okay, so x plus y, here you have, so between x and y you have OR operator, so both are 0, then only it is 0. Here it is going to be 1, 1 and 1. Now it's a whole bar, whole complement, completely for x plus y. Complement means whatever the x plus y values you are having now, you write the complement of that one. Okay, so it's an x plus y. So now x plus y bar. So 0, its other value is 1. Complement of this one is 0, and here 0, and here also 0. And of course we need actually, sorry, one more column I require. So it's about what? X bar into y bar. X complement into y complement. Of course this dot is not required to show. So here what happens? X bar column, y bar column. So consider them and apply the AND operator. So AND operator says answer is 1 when all are 1. So here in this case you have both 1. So answer is 1. Here 0, here 0. So remaining all are 0. Okay, now we'll compare. So we have to compare this x plus y whole bar column, this one, x plus y whole bar column, sorry, x plus y whole bar, this side, x bar into y bar. This is the column. So this is LHS, this is RHS. Just observe. So both the columns are same. So we can say final conclusion. In the above table, the columns x plus y whole bar and x bar into y bar are identical, hence it is verified. Okay. So when it is to be verified, we will be having equations. So we will be having equals to symbol. On either side we will be having expressions. So you just solve the left side expression as well as the right side expression. Finally, we will compare those two columns. If both the columns are having same values, then we are going to say it is verified to be true. Okay. Now we will go for the one more type of problems. Okay. Question number 2. Here I am having 5 problems. Now we'll consider that second type question. In that, say we are having 5 problems. Consider the first one: x bar, y bar, x bar, y bar plus x bar, y. Okay. So here we are having 2 different variables. So here it's about the preparing of a table of combinations. It's nothing but what? Truth table. So question may be either something like prepare a truth table for the given expression, or it may be prepare a table of combinations for the given boolean expressions. So here it's not about anything like proving. Okay, as we are seeing 2 problems where we need to prove. Okay, so equals to symbol is there. These are the equations. Now you don't have equations. Expressions are there, so just we have to prepare the truth table. Okay, so let me consider this first one: x bar into y bar plus x bar y. So 2 variables, the combinations are going to be 0 0 0 1 1 0 1 1. Okay, so next I want x bar as well as y bar. Okay, say x bar and this y bar. So just the x column values, consider those values and write the reverse of that. Wherever 0, take 1. Wherever you are having 1, take zeros. Now y bar, refer the column y. So wherever 0, 1, wherever 1, you go for 0. Okay. Now we want x bar into y bar. So go for one more column. X bar into y bar. So considering these 2 columns, we have to go for AND operator. So if both are 1, then only it is 1. Okay, so in the remaining cases, we don't have all as 1. So all other are going to be zeros. Next, we have to consider x bar into y. So x bar column is ready. Okay, then just y means we are having here. So x bar into y. So these 2 columns, x bar and then y. In between dot means AND operation. So if both are 1, okay, these 2 columns. If both are 1, so here only we are having both are 1. Only in that case it is 1. In the remaining cases, it is going to be 0. Okay. So still we have not solved the complete expression. So complete expression is this one. Okay. So now we are having x bar into y bar here and x bar into y here. Now we can go for the last operation, OR. So we are following the precedence rules. Now we will go for this x bar y bar plus x bar y. Now these two columns, this one and this one, in between plus. So we have to observe these two columns go by pair of values, and if both are 0, then only it is 0. So here both are 0, so here 0, here also it is going to be 0. So here you are going to have 1. So this last column is going to be an answer for us. Okay, so this is the complete expression, x bar into y bar plus x bar into y. So whenever expressions are given to you, you come by taking the different variables. How many different variables are there? So here only we are having 2. So you will just write 2 variables and the combinations, possible combinations for x and y. Then you go for solving the expression part by part, and finally we will come to the complete expression. Okay. Now we will consider the second problem. In the second problem, if you observe, we are having 3 different variables. Okay, so first time we are having 3 different variables. See here, apart from x, y, even we are seeing a presence of one more variable, say z here. Okay, so of course it's a z bar. So we are having 3 different variables. So according to this formula, 2 to the power of n, now we are going to have 2 to the power 3 because of the 3 variables. 2 cube means now 8 possible different combinations of zeros and ones. Now these are the x, y, z. So I told you to write the combinations of zeros and ones in the order of their decimal equivalents in the increasing order. Okay. So first you write the combination which is actually equivalent of decimal 0. Okay, triple 0. Then 001. It is binary equivalent of decimal value 1. So then the binary equivalent of decimal value 2. So likewise you continue. 011, 100, 101, 11, 011. So it's nothing but actually decimal value 0, its decimal value is 1, 2, 3, 4, 5, 6, 7. So as I told you, traditionally we are following this order, which is nothing but writing the binary combinations in an increasing order of their decimal equivalents. Okay, 0 to 7. Okay, anyhow, just observe this one again. So or else, so you follow one more method here. What you can do, you write first in the first column, you write 4 zeros, then 4 ones, then half of that. You start with 0 always. So again you start with 0, but here you return 4 0, half of that 2 zeros. Then you write 2 ones, 2 zeros, 2 ones. Then moving to the next column, again you divide half of the previous case. So here again start with 0. Here you return 2 zeros. Half of 2 zeros means only 1 0. Okay. Then 1 0 1 0 1. So 4 0 4 1, 2 0 2 1 2 0 2 1. Then here alternatively you write 0 1 0 1. Okay. So automatically what happens? It is going to be in this fashion, in a decimal equivalent in an increasing order. Okay. So it is not necessary right here. So just follow this traditional way of writing the combinations of zeros and ones. Okay, after having that x, y, z values, now again observe the question. So in this question, we need x bar, even there is a y bar here, and z bar. Okay, so x, y, and z are complementary. So whatever the x column, you just write the reverse of that one. Here 4 0 4 ones, so it's going to be 4 ones 4 zeros. Then y bar, okay, 2 zeros are there, so write 2 1 2 zeros 2 1 2 zeros. Now z bar, here it is 0 1, then it is 1, it is 0 1 0 1 0 1 0. Okay, now we'll go for this part of the expression. Okay, so x bar, y, z bar. So means 3 columns you have to consider: x bar column, y column, z bar column. So in between is nothing but dot dot. Okay, so we are having AND operators. So AND operators in between x bar and y, then with z bar means what? If x bar, y, and z bar all are 1, then answer is 1. Otherwise, it is going to be 0. Just we follow this one. Whether it is 2 variables or 3 or any number of variables, you just concentrate on the property of AND. So now, if all are 1, then only we are going to write as 1 here. Okay. So x bar column is this, y is this, x bar, y, and z bar. Okay. So x bar, y, and z bar. Okay. So these three all are not 1. Okay. Here it is 0. Here we are having 1. Okay. So x bar means this column. Here we are having 1. In place of y we are having 0. In place of z bar we are having 1. So here we are having 1. Here we are having 1. But here it is 0. So finally it is going to be 0 because as all are not 1. So next, if you follow just like that, here all are not 1. Here all are 1. So 1. Here no. So we are not getting all as 1 except in this case. Okay. X bar, y, and z bar. Only in this case we are having 1. So remaining all other cases are 0. Okay. Now, other part of the expression. Take this one. X, y bar. So if nothing is there means it's dot. It's dot means and means now 2 variables are there. If both are 1, otherwise 0. Column x and y bar. This is x column. This is y column. Y bar column. If both are 1, then only here I am going to write 1. Okay. X into y bar. No, no, no. Yes. Both are 1. 0. Here also both are not 1. So it is 0. So here also we have observed both are not 1. X into y bar. Now we will go for the complete expression. So this is ready. This one is also ready. Now we will go for the OR operation according to the precedence rules. First we will follow the complement operator, not operator, then we will go for the AND operators, then we will go for the OR operator. So we will go for OR operation. So these two, we will write complete expression x bar, y, z bar plus x, y bar. This complete expression I have written here. Okay, now this x bar, y, z bar is here, x into y bar is here. Between these two we are having OR operator. So both are 0, answer is 0, otherwise 1. So now just observe it. Both are 0, yes. Both are 0, yes. No, yes. Both are 0. Both are 0. So remaining cases we will write 1. So now this is the answer. Okay. So final answer, what is the answer of this expression after preparing the truth table means what? You first write the combinations of x, y, z, zeros and ones combination in increasing order of their decimal equivalents. So 0, 1, 2, 3 up to 7. Then what is the answer is 00, 10, 11, 00. Okay. Let me check the answer first. Question is x, y, is x bar, y, z bar, x bar, y. Okay. 00, 10, 11, 00. So it is correct. Okay. So now second question is over. I will go for one more question. This I will solve and I will leave these two as homework for you people. Okay. So we will go for one more problem. The third one. Okay. So let me consider the third problem. Here instead of x, y, z, we are having some other alphabets. The alphabets are A, B and C. Okay. So of course, if you observe here in this question, we are having overall three different variables A, B and C. So how many possible combinations of zeros and ones means according to 2 to the power of n, 2 cube, number of variables 3, again 8 possible combinations. Only variable names are changed. So far we have considered only x, y, z. Now we are having say A, B and C. So that's why here I have written A, B and C. The combinations are as usual, starting from something like 000 to 111. So decimal equivalent 0 to 7 in an increasing order. Okay. So then if you observe this expression, nowhere we are having A bar. So no need to consider A bar here. I will leave that one. So I have B bar, okay, and even I have C bar also. So better don't write A bar, directly go for B bar, then C bar means complement of C. So B bar means this second column, okay. So here 0, it is 1. So reverse. Now C bar, complement of C, okay, 0 means 1. 1 means 0. Now if you observe here, we are having parenthesis. So we have seen here the precedence rules is something like this. First preference we have to give for the not. Second preference we have to solve involving AND operators. Then we have to go for solving OR operator. But whenever parentheses are there, first we will solve that part whichever is there in the parenthesis. Within the parenthesis, if the expression is bit lengthy, then again we have to follow these precedency rules within the parenthesis. Okay. So here first we will go for the inner parenthesis because there we are having this parenthesis, okay, within this one. So inner brackets have to be evaluated first, then we will go for the outer bracket, then we will go for the considering this variable A. So first we will go for the innermost. So it's B bar plus C. So in some order we have to go. So here B bar plus C. So B bar is here, C is here. Okay, between plus means between these two values, go for logical OR operator. So logical OR operator says 0 if both are 0. So wherever you are having both are 0, you just write first 0. Whenever you see both are as 0. In the remaining cases, now you put ones. Okay. So this inner parenthesis we have evaluated. Then we will go for OR means plus with C bar. So B bar plus C plus C bar. Okay. So B bar plus C, here we are having that column, then it's just C bar. Okay. So C bar is here, B bar plus C is here. Now between these two, B bar plus C and this C bar, between those two we are having again both are 0, then only it is 0. So between these two, both are 0, no, both are 0. So now when we are having both as zeros, so then that's why it is going to be all as 1. Okay. Now we'll write the complete expression. What is that complete expression? Outside we are having the variable a. So complete expression a of b bar plus c bar. So this complete expression within the outer bracket is evaluated here. So this one with logical AND to the variable a. So this column and this first column you have to see. And dot means logical AND. So logical property. If both are 1, then only it is 1. So you just observe for both are 1 between this column A and this one. So here these two vanish. Wherever you see both as 1, then only it is 1. Here also both are 1. In the last case also it is both are 1. So here all are 0. Now this is the final answer for the given expression. A of b bar plus c, then plus c bar. Okay. So we'll just check the answer. Okay, 4 zeros, 4 ones. 4 zeros, 4 ones is the result. So still you have two problems here. Okay, D and E. You consider them as homework. Try to solve them.